Sometimes mathematicians' noses drip. I only have one nose. Whatever. Hi. We're going to tackle part B here, and now it's going to be, let's talk about the midpoint. Hopefully we've got that distance thing figured out, that we can tether that thing to the coordinate system and just start counting. That'd be good. Or we can let it be wherever we want to, and we can put on a coordinate system and look at the addresses and compare the changes in x's and y's, and say Pythagoras can help us with that. Now we're going to talk about halfway there. We're going to talk about halfway there. And maybe I'll go back and I'll put the rest of that picture on there. It's what we had before the previous episode was some type of rectangle, sides of 3 and 4 for the lengths, and we were doing some coordinate geometry, right? So the question was, when I'm halfway between this corner and that corner, where actually am I? Now we already said we could figure out the distance there. This is a 3, 4, 5 triangle, so I would have gone 2.5 units. But that still doesn't tell me exactly where I am. Maybe this is a map. Maybe this is the globe. We're looking at coordinates. Where am I? Am I at Costco? I don't know. Get lost in that place. So this one's pretty simple and straightforward. Like intuitively, you could look at this and say, well, if this length is 4, then like halfway on the x-axis would be at 2. And then halfway on the y-axis, if it's 3, it would be at like 1.5, right? So I'd get, for the x, I'm at 2 from there, and here I'm at 1.5. And that's right. It's a pretty good guess. This is exactly where you are, because you're taking the midpoint of both sides, and that's giving you the midpoint of that third side, that diagonal. And that's exactly what you're looking at. Visually, that's what's going on. Let me change that problem a little bit so that it's a little bit harder to do. And that would be this, where now this is 3 and that's also 3. And so we're talking about what's the midpoint of this one. Well, the length is kind of a weird length, isn't it? Yes. The length is now, what, the square root of 18 again. 2 root 3. So half of that would be, the distance would be root 3 would be there, and another root 3 there. But the actual address is not so bad, because we could still take the midpoint of this x side and say, well, that would be at 1.5. And half of this is also 1.5. There's my address. There's my address for that point. Okay, that's one way to think about this, is do something like that. Midpoint of this side and the midpoint of this side equals the midpoint of that third side. That's pretty cool, okay? Like, you don't have to guess. You can see that it's right there. So I like that, the midpoint. That's pretty cool. Now, if we're in coordinate geometry, we kind of do need to know where these endpoints are, the address of the vertices of this triangle that we're dealing with. This would be 0, 3. If we have the addresses of these things, maybe we have the address of these two right here. We've got that tethered to the corner, then what we need to do is basically average. Average is finding a midpoint, right? It's halfway between this thing and that thing. So what we're doing on this side is we're averaging 0 and 3. And to average it, you take those 2 points and you divide it in half. That's what we did. And over here, we're doing the same thing. We're averaging this point and this point here. So that would also be 0 and 3. We're finding halfway between the x values and the y values. Your official version of this in your book is like, let's take our x coordinates and average them, or divide by 2, and take my y coordinates and average them. I don't really like that. I'd rather do this, x bar and y bar. What's the average of the x's? What's the average of the y's? Now I want to take this one step further. I want to put this somewhere else than tethered to 0, 0, so that we can see that it doesn't really matter where our 2 points are on the map. One of our points We don't need that. We don't need that point there. So I'm gonna go over to the other camera really quickly and do a little bit of stuff on my grid paper. Lefties rule. All right, I picked a couple of points here that don't go through that 0, 0 point there. I've got -5, -7, and I've got the point 7, 2. And we could find the distance between the 2 points, but that's not what we want. But I'm going to draw that line in there. What I want to know is what's the address of halfway between this point and that point, because that would be the midpoint. If I wanted to, I could turn this into a little triangle, turn it into something that Pythagoras can help me with by just putting some dotted lines and emphasizing the fact that I've got a 90-degree angle there. But I don't really need that. I can average the x's and I can average the y's. I could take a good guess, though. I could say it's somewhere around 1, -2, but I'm not really sure. I don't want to just guess. So what we'll do is we'll go ahead and use our formula. And so we got to pick out our two x values, which would be -5 and 7. So we want to know what's halfway between -5 and 7, and that would be 1. Well, let me check out what change that is. That's a change of 12. Half of that is 6. Oh, sorry, yeah, it's a difference of 12. So if I'm just going to do it picture-wise, that'd be 6 from this point. 1, 2, 3, 4, 5, 6. It should be there. That's my midpoint. But the math tells me the -5 plus 2, about 7, is 2. 2 divided by 2 is 1. The y values, well, let's average those. My y values are -7 and 2. If I'm just going to do the math up here, -2 and 7, or -7 and 2, sorry, is -5. Half of -5 is -5/2. Or -2.5. Well, that probably would have been a good guess here because the distance here is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got to go up 4.5. 1, 2, 3, 4.5. And lo and behold, look at where I am. I'm at -2.5. I kind of like being able to do it with a picture, though I know the math works. It's just you got to remember you're just taking those two and you're averaging them. You're finding halfway between the two of them by dividing by 2. So that means that my guess of what 1 and -2 was awfully close. I didn't draw this perfectly right. It should be like right there. But that's that address right there. It's at 1 and -2.5. You can use either method that you want to. You can either turn this into a triangle, find the midpoint here by taking half of that distance, finding the distance this way and taking half of that, and there's how far you'd have to go from this one to get there. Or you can add together your two x coordinates and then divide by 2, and then you can take your two y coordinates and divide that sum by 2. But coordinate-wise, you're just looking at halfway on the x-axis that you've made, or the x side of your triangle, and then halfway on the y side of your triangle, and you can just go over and up, and you've got your new point. You've got your midpoint. So make sure that you got those two formulas. They're going to ask you about both distances, and they're going to ask you about midpoints. And yeah, both of them are pretty easy. We're just using Pythagoras, and we're using a little bit of coordinate geometry. Hopefully that helps, and you bring some good questions to class.